Analyzing comparable scenarios. Now it is easy to make comparable analyses. If Joe were to make decisions on the means or averages, he would have to compare the mean line on the comparison table. On average, his current situation would imply a mean annual profit of close to $111,000. However, if he were to fire one cousin and remain with only one worker and reduce capacity, his mean profit would increase to close to $113,000. On the other hand, if he were to hire an additional worker, thus increasing his capacity, his expected profit would rise to $119,000. In other words, from an expected or mean point of view, he is better off with more or less capacity. He should make a decision. If he were to only look on mean profits, the clear decision would be to hire another full-time employee, since this last or third option generates on average the maximum mean profit. Let us now consider the risks of all options. On downside risk, consider that Joe has already established on his mind a critical value, $60,000. This is the minimum amount that he requires annually to fulfill his household needs. If he were to earn less than that amount, he would be placed in a critical situation, probably forcing him to ask for credit loans and getting in debt, which he abhors. By taking a look at the probabilities calculated on the probabilistic bar to the left side of $60,000, we are able to assess corresponding likelihoods. If he were to remain on his current status of not hiring or firing full-time employees, the probability of a negative outcome less than $60,000 would be of 5.6%, approximately 1 every 18 possible outcomes. However, this probability decreases to only 1.1% if he were to take the conservative approach of downsizing his operations by firing his cousin. On the other hand, by hiring another worker, the probability of a bad outcome increases slightly to 6.8%, approximately 1 every 15 possible outcomes. Therefore, if Joe were to be a very conservative or risk-averse individual, he would probably choose to downsize operations by firing a worker and significantly reducing the likelihood of a bad outcome, while slightly increasing his expected annual profit by over $2,000. On the other hand, if he were to consider upside risk, that is, the probability of generating more than $150,000 a year, the option to hire another worker would be favored. He would be doubling his probability from 11.2% to 22.4% by increasing his payroll. In other words, instead of expecting a good year in 1 out of 9 possible years, he would now be getting a good year almost 2 out of 9 possible outcomes. In other words, a risk-prone individual would probably favor this third option of hiring another full-time employee, whereas a risk-averse individual would choose to fire one worker and simplify operations. In any case, it is clear that he has to make a decision to move out of his current situation, which is not optimal either from a risk-averse or risk-prone point of view. 94. Once you have closed this comparison chart, proceed to save the workbook in Excel. At-risk intervenes here by allowing to choose what type of saving you want to proceed with. By default, at-risk will save the results of the previous simulation on the same workbook file by adding, in this case, additional size to it. This option carries the advantage that the next time you open the file with at-risk previously loaded, you will not have to simulate again to have simulation results available to be analyzed, reported, and graphed. Sometimes, on lengthy simulations, this could be advantageous. You can also choose to save the outcome of your simulation in a parallel file with a RSK5 type of file. The third option is not to save the simulation data. On this case, the size of the saved file will be preserved only for the Excel workbook. You will have to simulate again the next time you open this file if you want to analyze results of the simulation, though.